Welcome to The Explainer. Today we're going to talk about a part of programming that, let's be honest, a lot of people see as a total chore. But what if I told you it's actually the most critical and maybe even the most thrilling part of the job? Let's talk about testing and debugging. So, to get started, let's just completely reframe how we think about this. Forget the idea that testing is some boring final step. Instead, I want you to think of it like a high-stakes investigation. Think about it. Every bug? That's a clue. Every weird error message? That's a piece of evidence. And you're the detective on the case.
And get this, the source material we're diving into today basically says that hunting down a bug isn't just necessary work, it's a thrill. It's like you're at the final boss level of a video game. The challenge is intense, sure, but that feeling of satisfaction when you find that one single elusive error, it's huge.
To get to that point, you've got to develop what our source calls a tester's mindset. Now, this is a totally different way of thinking that goes right alongside the creative programmer's mindset. It's all about being a little skeptical, always curious, and super methodical, just like a great detective.
So why all this focus on testing? Is it really that big of a deal? Well, let me tell you, bugs aren't just for small-time projects. They happen at the very highest levels of the tech world. Let's look at a pretty famous example.
Look at this. Even a tech giant like Microsoft has had some really public struggles with Windows 10 updates. We're talking about the infamous blue screens of death, people suddenly losing their internet connection, even user files getting deleted. Scary stuff. So here's the thing. If a company with basically unlimited resources can struggle this much, it proves that nobody is immune. This isn't really about bad programming. It's just about how incredibly complex modern software is. Okay, so if bugs are going to happen no matter what, how do we keep them from causing total chaos? Let's pull out the first tool from our detective kit. This is all about managing errors right inside the code before they can bring the whole system crashing down. And that tool is this brilliant concept called exception handling. Here's how it works. Instead of letting some unexpected error just stop your entire program dead in its tracks, modern programming languages build in a kind of detour, a separate path for the code to take when things go sideways. It keeps the normal, happy path totally separate from the logic that handles errors. And as you can see here, while the main idea is the same everywhere, the exact language, the names for these exceptions can be different. So whether it's an out-of-range error in C++ or a null reference exception in C#, every language has its own dictionary for describing what went wrong.
Now this is where it gets really cool. This slide shows a super common pattern called the try-catch-finally block. Think of it like a plan. First, the program will try to run some code. But if something goes wrong, let's say it tries to divide by 0, the error gets caught and a completely different set of instructions runs instead. And then, no matter what happens, good or bad, the finally block runs to do any cleanup. It's just a really elegant way to plan for problems. All right, so we've got tools like exception handling for managing errors in one little piece of code, but what about hunting for bugs across a massive, entire system? Well, for that, we need to zoom out and look at the bigger strategies.
And two of the most powerful strategies are right here. First, you've got divide and conquer. It's pretty much exactly what it sounds like, right? You take a huge, complicated system and you break it down into smaller, bite-sized pieces so you can test them one at a time. Then there's unit testing, which goes a step further. Here, you actually write tiny automated tests for every single unit of your code, like a single function. It's like checking every single brick to make sure it's solid before you even think about building the house. This idea of taking testing super seriously and putting your best people on it, it's not some new fad. There's this incredible story from the US space shuttle program that just nails this point perfectly. So get this. Back in the 70s, the space shuttle program had this bizarre policy. If a tester was really, really good at finding bugs, they got promoted right out of the testing group and onto a development team. They were basically punished for being great at their job. And the result? The testing team was completely drained of its top talent. This led to massive delays and persistent errors in a system where, failure is not an option. What a powerful lesson, right? If you devalue testing, you're pretty much setting yourself up for failure. So that was then. What does this detective work look like today on the modern frontier? As you can probably guess, the challenges have only gotten way more complex. Yeah, today, the detective work often looks a lot more like espionage. There's this whole field called penetration testing, where programmers basically become ethical hackers. They're actively trying to break into their own systems, using the same tools a malicious attacker would, all to find those security holes and patch them up before the bad guys can find them.
And maybe the single biggest change in modern software is the cloud. To really get a handle on the new testing challenges this brings, our source material has this fantastic analogy: pizza as a service.
And this chart just lays it out so clearly. On the far left, you've got on-premises. That's like making a pizza totally from scratch at home. You're managing everything: the dough, the sauce, the oven, the whole shebang. But as you move to the right, towards SaaS, software as a service, it's more like just ordering a pizza for delivery. The restaurant handles almost everything. So your job as a tester completely changes. You're not checking the oven temperature anymore, you're just making sure they sent you a pepperoni, not an anchovy.
So, because of this shift, when you're testing in the cloud, your whole focus changes. You're not worrying about the physical servers anymore. Instead, you're asking questions like, hey, can our app handle a sudden million-user spike? Is our customer data totally secure and separated from other companies on the same cloud? Does our service play nice with other apps? The entire environment is different, so the tests have to be different too.
And believe me, it does not stop there. The world of testing is constantly expanding into these new, mind-blowingly complex areas. We now have entire disciplines for testing things like big data systems, the billions of devices in the Internet of Things, AI and machine learning models, even blockchain. And every single one of these brings a whole new universe of challenges.
Okay, so after all that, the detective work, the big strategies, the modern frontiers, what's the big idea here? What should we take away from all this?
The source material leaves us with this really powerful thought. Testing isn't some separate, boring, mechanical task. It's an essential, inseparable part of the art of programming. You know, programmers are the invisible artists and architects of our digital world, and testing is the part of their craft that makes sure their creations are strong, secure, and, in their own way, beautiful.
And that leaves us with one last thing to chew on. After all this, is programming an art, a science, or a detective story? You know, the more you think about it, the more it seems like, to do it really well, it probably has to be all three.